Let me record it. So, so developer is writing code and infrastructure guys prepare the infra. So who will do the deployment? This is the question arises, right? How can we use this infra to put this code in somewhere so that the customer can read, customer can access?
These two teams will interact together. So development team will give a set of instructions to operation team to what to deploy.
Right. So in that case, if development team is giving instructions to operations team, always, you know, the people like operations team, they doesn't know about the coding, which language you're developing, C, C++, Java, or like Angular, React, Python, what are the language, .NET framework. He doesn't care. He doesn't know what exactly the language also. Not even a single syntax of that. So he doesn't understand that code completely, right? Yeah. So you have to create some package from that code. So that process is called build. Okay. Developer doesn't know, operation doesn't know what exactly the code it is. So, okay, let me put it this way. Code plus some instructions can become a package. This process is called what? Build. And there are different build process for each and every language. Okay. Java, we use Ant, Maven, Gradle. Ant is the old school way of doing the building a package. The output of this build operations can be a zip file, jar file, or a var file. Zip, you know, right? .zip format. Yeah. And jar is nothing but Java archival file and archive file. People call it as, depends. And then a var. Var is stands for web archive or web archives. Okay. So this is the output. You have to put it in the infrastructure. Now, again, the comes, okay, build process, somebody has done it. Okay, in the developer itself, he has knowledge like how to write the code and how to build the code also. Fine. Now we got the package. Now, how can you place in such a way so that customer will reach? So you should have some servers. So those server can be a combination of hardware and software. What is hardware? Hardware is something but a physical RAM, memory, RAM, like a virtual CPUs or like a physical CPUs, and then your machine, something like your machine, anything which can has a memory, CPUs and storage and IOPS between those things, network, because it has to be put over the internet, right? So it has to be in the network, and then it has this DNS entries, AD entries. DNS stands for domain naming system. If customer is hitting the www.ecart.com, so it has to reach this particular server. So there should be something should be mapped with the ecart to the server IP. So all those things we'll go in detail, but yeah, I'm just talking about those things. So somebody has to be mapped all those things. So that is called a server. Server has that properties, all those properties. Now, somehow operations guy is expert in that, so he did that. Fine. But this is a hardware, like this is a hardware part. What is the software part in it? It can be a web server or a DB server, yeah, application server or anything, right? So this particular software, the piece of code has to be placed in such a way that customer can hit that code. So that can be a web server, app server, or anything.
I didn't understand the point. So web server and app server, will they like, do the developer create it, or do they just write the code to implement in
no,
server?
Forget about this, who is creating or what, who is, I'm just explaining you the process.
Okay.
So the web server can, we'll talk about those things later, like who is responsibility and who is what, all those things in later. But the thing is, there should be some container, right, to process your request. Suppose, let me ask you a question in a reverse way. Suppose if you're hitting www.ecart.com, you're seeing the front page. How can you see the front page of that website? Because on the server side, when you hit www.ecart.com. Okay, what is ecart.com? Guys, speak out, man, so that we can talk
I'm
to
not
you.
aware of it.
Yeah, Mohan and Krishna.
That is one of the web application, right? We can say simply ecart.com is.
No, ecart. What is exactly ecart.com? Domain. Perfect. Yeah, domain name. So domain name must have something mapped in the background. What is that? IP address, right?
Yes.
Every domain name has IP address. You agree or not?
Yeah.
One IP at least, public IP, right? We'll talk about public IP, private IP, all those things later. But yeah, domain name has a IP address, right? So that is a DNS provider, or like DNS, what do you call it, entries directory system. They will have this entries everywhere. That's a different story. But when you hit ecart.com, it will be hitting to the particular IP, like something like 192, not 192, 32.22.32. Something like some public IP address. Okay.
Yeah.
So that IP address is your server IP. That server has two properties. One is hardware, other one is software. The hardware is the which I talked about, like a memory, CPU, and all those stuff. Then what will be the software? Software is that something like, how can I suppose? Okay, let me open the browser. Let me do one thing. Let's write a simple HTML code. Okay, I'll write this here, HTML code. Or I can put a simple H1 tag. Welcome to DevOps world. DevOps 10. Okay, close HTML tag H1. This is the way of closing tags. And this is the HTML tag close. I'm just write a single code of a HTML page. Let's save this file as what to save engine. Yes, save. So choose all files and call it as sample. A sample of anything, a basic HTML. I'm saving conventional .html. Okay, and I'm saving at documents, a desktop file, like documents. Okay, the file is saved. Let's open browser. Now I wanted to open that file. Just type the Control O. What was the file name?
Basic.html.
Basic.html.
In documents, it's in documents.
Documents, I put it in documents.
Yeah, over there.
You just kept it on. Yeah.
So see, now this is address in case of yours is www.ecart.com, right? Now how this page is displaying, what is the server software component here?
Your laptop.
The browser. The browser is a component which has the ability to serve the web request, right?
Yeah.
It can be our web server, right? So that is the software part, web server or app server or DB server, like what you all use for that hardware. You have to use it, right? So in DevOps, you just remember 4 components, web server, app server, DB, in between somewhere cache will be there. What are the components? Web, service, or like app server, database, and cache. That's it. Any architecture you can think of DevOps world, this can be a combination of all those things. The amount of servers will be vary, and the amount of software, the type of software they use will be various, but more or less this is the same. Web service, DB. Service can be app server. I'm calling sometime. I refer to service. It depends on organization to organization, the convention will be changed. Okay, now we prepared operations guys. They feel that, okay, installing software on server also is our job. They installed it somehow. Now, how can you place your code, the developer code on that machine so that customer is hitting e-card, he has to get the web page. So that process is called deployment. What is a build process? Build process is something that after writing code, add some instruction to create package so that it can be deployable. That package can be a zip file, a WAV file, a jar file. This process is called build. And once the server and infrastructure is built by the operation team, and if you are placing your package in some place so that customer can able to reach that, this process is called deployment. Okay, is that clear?
Yes, boss.
Yes.
So if you want to deploy, if you want to define the build and release process, that is called as release. When it is available to the customer, then it is called release. The release happened. And you know, when software development is in progress and it's in the lab, if it is not making, it is not releasing to the customer, then it not generating any revenue out of it. It's a zero. In fact, that's a negative income, because we are wasting so many resources to develop that application, and that is not yet released. That's the reason DevOps engineers are crucial, because they play a vital role in build and release. So once the software gets released, the client, the people, the company, the organization is generating the money out of it, revenue out of it. Otherwise, it will be a waste product if it is not releasing properly. That's the reason DevOps are very crucial. They play a very crucial role in these activities. That's the reason they ask you, or like they pay you some money, like depends on the your experiences and all those things. For considering those things, they will pay you the money, and that's the reason you will be having more number of openings. Every project you think of, there should be at least 3 or 4 DevOps engineers required for every project. I'm not talking about every company. Every organization might have multiple projects they are doing, right? Forget about they are deploying, they are providing service in real estate, that they're providing service in e-commerce, they are providing service in health, pharma, whatnot, digital marketing, or anywhere. If you think of any area, there should be 3 components will be there: web service, DB, and some DevOps engineer has to be in place so that he has to understand the process and deliver it to the customer. This is service based. And if you are defining, if you are working at a product company, like if you are designing some products, they're not so same process. That's why DevOps has like more buzz like in the market, as well as in terms of openings, as well as hiring also. And at the same time, the role is critical. You can't like relax. Okay, nothing is going on. You won't get any work. Developer can be relaxed sometimes, but not the operations team. He has to be all the time DevOps guys. Now, slowly, what happened in the movement? The operations team is doing only these things: network things and storage thing and compute thing. Compute thing is also because of the public cloud evaluation. We are only spinning up the infrastructure in the cloud, so we are not depending on the operations team. And storage also, because of public cloud evaluation, we are getting storage, networking, and computing, everything over a public cloud platform. So we don't require ops team now. All we require is DevOps team. He has to understand the process and deliver it to the customer. So this is the state where we are having this kind of model. Okay, if it is on-premise network, public cloud platform, I understood. Like we can create one account, we can get the resources by using the credit card or whatever way we are follow. That's okay. But what about if it is on-premise data center? Then who will leverage the data center activities? So data center activities, operations team will be there. Those can be people are storage team, network team, or data center ops. They will leverage you the infrastructure for you in terms of VMs. Once you got those VMs, because or physical boxes, once you got VMs or physical boxes or whatever the thing, the infra, then as a DevOps engineer, you will be responsible to use those infra to deploy this application. So this is the process. Now, it's not like you're filling the gap between dev and ops. You are the DevOps, nothing is there. The definition is in the past, like there will be a tools team who is building the infra and dev team who is writing the code. So somebody has to be in the intermediate to build this package and deploy it on the server and create those servers, not the hardware part, the web server installation part, app server installation part, and configuration, and then installing the, deploying the application. So this is the previous generation of definition of DevOps, that filling or bridging gap between the dev and ops. But now there is no such team, which is like because like, or even data center evaluation, or like the in terms of public cloud evaluation, we are getting click away the infrastructure. So as a DevOps engineer, you have to use that infra and solve the developer problem to deploy the application and also reach to the customer problems. If it is not able to reach the website, ecod.com, what happens? The customer will be raising a support ticket. So that support ticket will route it to you, right? Not to DevOps, not to developer first. It will reach to the DevOps team first. Man, this website is not working. Can you look into this? So then we have to troubleshoot whether web server is working or not, or web server is in start state or not, or like the code is available to the customer or not, all those things. So those are troubleshooting part. We'll discuss those later, but this is how it has to work. It will work. Now, did you understand what is the DevOps definition? And what is the role? And what is the crucial thing or criticalness in that? And what exactly the people are looking to get?
Yeah, I understand.
Yes,
Okay, right? So now let's talk about the roles. What can be the roles of DevOps engineer? Now, you tell me guys now. What are the DevOps engineer roles? Let me clear this, Control N. Yeah, each one guy, one role. It shouldn't be same, okay? Yeah, go on.
Creating infrastructure. Creating infrastructure.
Okay.
And deploying this build also, right?
Okay. Let me correct your words. Who said the deployment activities?
It's me, Swas Mohan.
Okay. Build and release. In one word, I'll define. Okay. Is that correct? Which you're talking about this one, right? Build and release.
Yep.
Yeah.
Okay.
Yeah. Okay. Fine. So what you added, infrastructure, right? So on-premise, it can be on-premise infrastructure or public cloud or any cloud.
Or we can say provisioning infrastructure.
Yeah, that's what I'm saying. On-premise, infrastructure provisioning, or cloud. Okay. I can call it as a one third activities. Not only provisioning, you have to do all activities, right? So let me call build and release and on-premise or cloud activities. Yeah, go on. Next.
Minimizing the downtime and monitoring the application.
Okay, I'll consider you for the monitoring the application. Okay. I'll call it as this 5-1. Practical monitoring, I'll use the word, because there are a lot of things to monitor. So which one you'll choose? That's a practical monitoring thing. Okay, yours is right, Krishna.
Yeah.
Yeah, next. Third one. I'm not going in order, I'm just putting practical monitoring is done. Okay. Build and release is done, and on-premise and cloud activities or cloud platform activities, or yeah, cloud activities. Next.
Maintaining.
Maintaining. How will you maintain those things? Suppose if you are deployed application on a server 1 and that server is down, and you're troubleshooting that server to bring up, but unfortunately that server is not coming up. So what's alternate plan? You have to spin up another server to place the code and serve it to the customer. Once again, how much time it will take to add a new server to the existing stack? So those kind of activities, how will you automate those things? Or how will you minimize the downtime for that? Like, how will you minimize the downtime to the customer? So these activities comes under configuration management activities. Okay. How quickly configure the server, all those things. And this is the earlier case, the old school of legacy. I call it as legacy or old school deployments. There will be a Jenkins tool or like some kind of build and release tool, which can create the package from the code using Maven or Gradle or Ant in case of Java development, or in case of Ruby, it will be NPM, Ruby gem, or like in case of .NET, it will be MS build, the build technology I'm talking. So there will be different kinds of build technology will be used, and the packages will get generated, and those packages can be deployed on the server as a WAR file or zip file, so that customer hitting the website, it will be routing to the IP, and then the request will be served to the customer, right? So to break all those things and to solve so many questions over there is a microservice architecture. So this is something which you not heard of, or like which you don't know about this microservice architecture. No problem. We'll talk about this detail when it comes to this area. Okay, you can achieve this using Docker and Kubernetes and all those things. We'll talk about those entirely in a different, like when it comes to that, we'll discuss about. As so far, these are the things. And apart from this, I'll add 5 more, or like not 5 more, few more, like somebody said troubleshooting, right? So troubleshooting is one area you should be good. And next one is something like storage and networking. I'll call it as in one place. Storage, you should have an understanding of storage and networking. Though these are the part of second on-premise and network thing, but I'm writing separately because these are the add advantage skills, not the core skills. And scripting, one language, Shell, Python, Ruby, Perl, whatever the language you comfort, PowerShell, it's up to you. But one scripting. And majority of the servers will be in Linux or Windows. What are the servers in the world, the real world? The server will be on a Linux platform. So you should have a Linux shell scripting will be add advantage, or like Perl, Python, Ruby. Okay. Apart from this, and ninth one is most important, common sense. Don't you think if I'm writing common sense as skill, yeah, absolutely common sense is required. Because I'll tell you one thing, when you want to fix something on a running train, on a track, train is the train is coming behind you, like it's approaching you in a fast of 100 kilometer per hour, and you're fixing something on a track. How crucial it will be your job, right?
Yes.
So that much crucial, critical responsibility you are, and sometimes your common sense won't work. So always stick to the basics. What exactly this process? Okay, what I'm missing here. So don't overlook any process, so that you can troubleshoot well. This common sense will help you to solve all these goals. Okay. Clear?
Yes.
Yes.
Let me
So,
put
that's
this.
like in real world, like it will be like every day is like any critical job. Only I mean to say like always we are working on critical instance kind of, or we will be having any SLA during that time also. I understood like
Okay, what is your previous role?
like I was into development and again in support. Like both I'm having.
No, what is your role? Which technology you worked on, or like what is the customer? What kind of problem you're solving?
What is my role means in a project like I am working as a lead, and what kind of customers means I was basically into oil and gas, telecom, and again banking clients also I work with. So what exactly you are
What kind
pushing?
of
I don't.
what kind of technical
Yes.
thing you should
Yeah.
solve? You'll be solving
Yes.
PLSQL
Yeah, it's Oracle mainly.
or some kind of database operations, right?
Exactly. Yeah.
Okay. So you're responsible for your database, right?
Like not database. I mean, development means there is no responsibility on me, right? Like once the code went actually, but in support means for the product actually, it may be
Right.
mix of
Right.
Linux and again whatever it is. Yeah.
Right. Right. When you write a code, if that code is not working, how often it will happen?
Yeah, that's what like I'm trying to understand here. Like in previous means, apart from this cloud and DevOps, like it will be we can expect like criticality. I mean, at least once in a week. But being a
Hmm.
DevOps engineer,
No, no, you can't guarantee that once in a week, every time you'll get a problem.
I don't know. I'm just trying to understand. That's why I'm just asking.
No, no, I'll tell you. That's your question is itself has answer.
Yeah.
When required, you have to support the for production first. Your priority will be production server support, and then if you're getting leisure time, your production is running smooth, then you have a chance to work on your sprint work.
Okay. Yeah.
That will be the role. And sometime what happens in organization, there will be a dedicated team for production support. And there is a separate team for DevOps. So DevOps, as a DevOps engineer, you have to spun up the infrastructure for the operations, and once hand over it to production team, they will take care of everything. If required, they call you, but they will support. So
Yeah.
this is a SRE model role. Got it?
So yeah, thanks.
So like it depends on organization, man. Like how the role will be different. So if you ask me my current role, like my sprint work is like 8 hours per day, right? The people who don't know what a sprint is, like it's agile model, agile methodology, will work on a sprint. Sprint is a duration for 14 days. So our task will be divided into eight hours per day, Monday to Friday, and two Monday to Friday will be 10 days, and 10 days. So the Saturday, Sunday is also in the sprint, but those are holidays, right? So 14 days sprint means actually 10 days sprint only, right? 10 into 8, how many hours you'll get? 80 hours, right? So in 80 hours of your work, the 40 hours will be dedicated to sprint and 40 hours is dedicated to production support in our case. If I'm not getting any production support during that week, so I need to focus on my sprint work. Clear?
Yes, boss.
So this is how we work here. It's like mine is into like a SRE model. DevOps and SRE combination. Like there are a lot of things which we'll discuss later. What is SRE? What is DevOps? When you're applying for jobs, I'll talk about those things. Okay. So most of the servers are Linux. Don't worry if this meeting ends, I'll create one.